In this example, number 7a, we have an equation for the supply curve that tells us the supply price is equal to 5 times the quantity supplied. And we have a demand curve that tells us the demand price is equal to 21 minus 2 times the quantity demanded. All right, so for this question, we want to graph the supply and demand curves, and then we want to actually solve numerically for the equilibrium quantity Q star and price P star. So let's start by graphing these over here. All right, so we're going to have the quantity on the x-axis, the price on the y-axis. Let's start with the supply curve. So the supply curve over here has an intercept of 0, so we're going to start here at 0, and a slope of positive 5. So let's draw that in. We start at 0, we have a positive slope, and we'll just label that S for supply curve. For the demand curve, we have a y-intercept of 21, so we're going to start up here at 21, and then we have a slope of negative 2. So let's draw that in. That's our demand curve. And again, the supply curve starts here at 0. The demand curve starts at 21. All right, and we know that the intersection of supply and demand is where our equilibrium will be, Q star, and the market clearing price at which both quantity supplied and quantity demanded are equal. So there's a couple ways we can actually solve for Q star, P star. One way would be to set the supply equation equal to the demand equation. In other words, figure out what this point is. What is the price and quantity at which these two equations are the same? So let's see how that would look. We would set the supply curve 5QS equal to the demand curve 21 minus 2QD. But since we're setting them equal, we know that the only place that supply and demand will be equal is at Q star. Okay, so solving for Q, we would end up with 7Q star on this side is equal to 21. Q star is equal to 3, right? And then we would take this Q star equal to 3 and plug it back in either into our supply curve and it'll spit out P star, or we can equivalently plug it into for QD in our demand curve and it'll spit out the demand price, or P star actually. The reason we can plug it into either the demand or the supply curve is because by setting supply and demand equal to each other and solving for Q star, we know that the same price for both the supply and demand curve will make that Q star manifest. All right, so let's take the supply curve just because it's a little simpler for this example. 5 times the quantity of 3 is a market clearing price of 15. All right, so that's one way to do it. Another way that's maybe a little more tedious, but is the way we're gonna try next, is to actually plug in different values for the quantity supplied and see what the supply curve spits out for the supply price, and compare that to the same numbers plugged in for the demand quantity in the demand curve, and then see at what point we match up on the supply and demand curve. So let's start with the supply curve. If we plug in 0 for supply, 5 times 0 is 0. If we plug in a 1, 5 times 1 is 5. Plug in a 2, 5 times 2 is 10. Plug in a 3, 5 times 3 is 15. Plug in a 4, 5 times 4 is 20. And we'll stop there for now and see if we've gone far enough to find a match with the demand curve. So on the demand side, if we plug in a 0 for quantity demanded, 21 minus 2 times 0, 21 minus 0 is just 21. If we plug in a 1 for quantity demanded, we get 21 minus 2, which is 19. If we plug in a 2, we get 21 minus 4, which is 17. If we plug in 3, we get 21 minus 6, which is 15. And if we plug in 4, we get 21 minus 8, which is 13. So now let's take a look. Did we find a match anywhere between supply and demand? Well, yes, we did. So we see that when the quantity is 3 and the price is 5, both the supply and demand curve match up there. So we know that the quantity, just like we solved for here, a quantity of 3 and a market clearing price of 15, we've now confirmed that with our second method. So I'm going to label that here. Q star is 3, P star is $15. All right, so then the next part of the question asks, if the price were instead $20 for whatever reason, would this cause a shortage or a surplus in this market? So let's start by labeling the $20 on our graph. So $20 would be somewhere here. Okay, so above our market clearing price. And we know that consumers don't like higher prices, but producers do. So not surprisingly, we see in the graph that at $20, the quantity demanded will be lower than the equilibrium, and the quantity supplied will be higher. Okay, so we're going to have a higher supply than we have demand, so we're going to have a surplus or an excess supply of our product. So how big will this surplus be? Well, to figure that out, we need to calculate the actual quantity demanded at a price of $20 and the quantity supplied at a price of $20. We can do that by really listening or looking at our graph. So if you want to figure out this quantity, well, we just need to plug in $20 into our demand curve right here, and it'll spit out the quantity demanded. And similarly, if we plug $20 into our supply curve equation, it'll spit out the quantity supplied at a price of 20. So let's go ahead and do that. When we plug in $20 into our demand curve and solve, we get 2QD equals 1, QD equals 1/2. So this quantity over here is 1/2, right? If we plug in $20 to our supply curve, we divide both sides by 5, and we get the quantity supplied when the price is $20 is 4 units. So over here in our graph, we can label that 4 units. So our surplus is equal to 4 units supplied minus half a unit demanded, so our surplus is 3.5. We have 3.5 too many units relative to what's being purchased.